Hello everyone, my name is Juan Felipe Parra, PhD candidate at the National University of Colombia, and today I will present to you this work in process titled Model for Scenario Analysis in the Inclusion of Non-Conventional Renewable Resources in the Colombian Energy Matrix. Colombia is a country highly depends on water sources for electricity generation. Almost 65% of the energy matrix is formed by hydroelectric plants. These conditions made the energy sector of Colombia a sector with low CO2 emissions and enough installed capacity to supply the demand. However, this condition also makes the system vulnerable to climate variation and uncertainties. That's the reason why the energy sector and the Colombian government are interested in introducing non-conventional renewable energy sources to the energy matrix. The introduction of technology like solar, wind, geothermal, or biomass energy into the matrix may introduce also complexity and uncertainty in the electricity systems. Some studies and some scenario exercises has studied the impact and effects of these technologies in the short term and the long term. However, these exercises tend to have a qualitative and a reflective approach. That's the reason why in this project we want to build a model to support and to validate in a quantitative way these scenario exercises. For the problem articulation and the first step in the modeling process, we use previous scenario exercise and we did interviews and workshop with experts and stakeholders of the energy system to determine demand variables and the drivers of the systems. We also did a review of different system dynamics models used to planning energy sectors, and we decided to use the Moxnes interfield substitution model as a reference. Additional to dynamic hypotheses presented in the Moxnes model, we add some submodels and dynamics that were interesting in the Colombian case. We include some submodels associated with reservoirs, with the market, and we split the model into 5 regions because there are evidence that in different regions of Colombia the cost of technology are different and also the climate conditions vary. At the moment we have some preliminary results. We have a structure of the model with almost 600 variables, and we at the moment achieve to fit the general installed capacity of the country with historical data, and we also achieve to simulate the tendency and the behavior of the reservoir and some prices signals for the real system. However, we are still in validation and calibration for specific regional variables, and we also expect to test the model's ability to be used as a basis for simulating prospective scenario. Thank you so much.